Hello, my name is Sunny Sun, and welcome to this demo webinar to get started with Istio Ambient Service Mesh. What is Ambient Mesh? It is an alternative technology to the Cycle-based service mesh that is widely used nowadays. The most compelling difference is there's no sidecar on the data plane. That means we don't deploy any sidecar next to a workload container to intercept and process its data traffic. Instead, an ambient mesh is woven with two salient components. First, a so-called cTunnel pod is deployed on each Kubernetes node to support layer 4 communication from pods to pods or from pods to services. And this is done through a zero trust, secure, HTTP-based overlaid network. Secondly, a so-called waypoint proxy is set up to attend specifically to each virtual service that requires layer 7 traffic management or content switching measures. Now, let's take a look at a sketch of the ambient mesh architecture and data flow. As you can see from this diagram, we have a 3-node Kubernetes cluster and a daemon set of cTunnel pod is deployed throughout this cluster, which means each Kubernetes node is carrying a cTunnel pod. For user workloads, first, we have a sleep client container. It is so named because it uses the sleep command to execute the container init process perpetually. And then we have the front-end application. And this is provided by the product page service. Again, it is available from the book info sample app. And the review service from the same sample app served as the back-end application. And in particular, the review service is to be delivered by 3 versions of the reviews pod, version 1, 2, and 3. Also, in addition, we defined a virtual service that determined the proportion of service traffic to shift between different versions of the reviews pod. So the data flow is actually triggered by the sleep pod opening an URL to the product page service. The request is to be processed by the product page app, by the product page application. And to complete the request, the application will invoke the review service at the back end. So data will flow from the sleep pod and flow through the local and remote cTunnel pod and land in the product page service pod. And then the pod initiate access to the reviews service. So data will be transmitted out of node 1 to node 2. So in doing so, the network traffic will flow from the local cTunnel pod to the waypoint pod on node 2. And here in the waypoint port, it will determine which reviews port to forward the request to, and then it redirect the traffic through the cTunnel port to the desirable version of the reviews port. One thing to note is that hidden from the diagram is a daemon set of istioed CNI port. And on each node, such a port is responsible for redirecting traffic from the user workload port to the local cTunnel port through IP tables. So now we come to the benefits of using ambient mesh. So first of all, without sidecar or in the absence of sidecar, user ports are naturally free from any intrusion or interference from the sidecar. And similarly, there's no sidecar to impose upfront capacity demand or incur utilization overheads. Another advantage is that it facilitates incremental adoption by allowing us to opt in layer 4 or layer 7 functionality separately. So in most cases, we will start from the outset using the cTunnel port. That cTunnel port is the one that provides the layer 4 functionality. It's only in the later stage of the project when we need to deploy special virtual service, then we will consider deploying the waypoint proxy to provide the layer 7 functionality for traffic management or content switching. Another advantage is that instead of doing the proxy work all over the place from source to destination, here it streamlined the layer 7 processing spatially towards the traffic destination through the waypoint proxy. So it means that we shift and confine the layer 7 redirection the logic to the side of the traffic destinations. So all told, the benefit is that without using or in the absence of the sidecar, we can avoid doing everything everywhere all at once. So now we come to the subsection of a hands-on lab. So first, the lab environment is based on a Ubuntu VirtualBox VM. And on this VM, we deployed a CAN-based 3-node Kubernetes cluster. And the bulk of the work in this demo borrowed heavily from the Getting Started guide available in the Istio website. So you can refer to this URL link for more details about getting started with ambient mesh. So here is the outline of the demo workflow. So first, we download and install the Istio alpha binaries where the ambient mesh part has been merged. And then again, we deployed the book info sample application. After that, we deployed the waypoint proxy for the book info to review service, because we want to define a virtual service for the book info to reviews for traffic management on layer 7. And to this end, we need to deploy the waypoint proxy. And after that, we show how to remove or undo our left and return the left to the original point. So let's start our hands-on demo now. So here is the Kubernetes cluster that we will work on. First, we run the kubectl command to survey the nodes. We have the control plane node and 2 worker nodes. And this is a brand new environment. So there's no user workloads in the default namespace. And here is the namespace. Here is the list of namespaces that are recognized by the cluster. So our first step is to download and install the Istio surface mesh, the ambient mesh. First, we download the binaries. Then we set the path. After that, we can install the Istio ambient mesh. You also note the option profile is set to ambient. So let's start installing the system. Yep, we complete the installation. Let's check out a few things. So here we have a new namespace called Istio system. It's already been installed onto the cluster, and you can. So as you can see, we have a daemon set of cTUN node that so there are 3 cTUN node pods. They are they, they are deployed on the 3 Kubernetes nodes. And also, as I mentioned briefly before, we also have this Istio CNI pod. It's also a daemon set uh, deployed on each Kubernetes nodes to take care of the network redirection from pod to cTUN node. Yet there are 2 daemon sets installed. And finally, we also checked that the Istio Ingress Gateway has already been deployed on the cluster as well. So we are done with the control plane part of the Istio system or of the Istio service mesh in the ambient mode. And now we are going to deploy the book info app. So as you can see here, um, each book info application pod just running one container on its own without any sidecar working next to it. So they can be brought up and running in a more, quicker way. And we deployed the sleep container. It will function as a client container to access the book info app. We also deployed the virtual surface for the Istio to Ingress Gateway. And this one is the same as the one we would do in a Cyca-based surface mesh. So we've got everything's up and running concerning the book info app, and they are the same as those we would try it on a Cyca-based surface mesh. So now we want to include the namespace, the default namespace in the ambient surface mesh. So we just label the namespace in this manner. Yeah. So we just want to try out the surface of the surface mesh. Use the client. Okay. Use the sleep client container. So first we access the Istio ingress gateway. In fact, the Istio ingress gateway is the same as the one we did on a Cyca-based surface mesh. So it naturally, so it has already embodied all the layer 7 logic to route to take care of the virtual surface on its own. So we've got the result we want, and then just access the book info app itself directly. The portal page, that is the portal page app. Yeah, you can access the portal page app application. And then we try to access the ingress gateway on node 2 on the client host. Yes, it also work. So now without or before we defined a specific virtual surface for the review surface, let us just access the portal page surface with this portal page URL path, as I mentioned in the diagrams in the architecture slide. And this URL will cause the portal page application to access the review surface at the back end, because we have yet to define a virtual surface for this review for review. So so it will use the default round robin load balancing method to rotate the request to the free versions of the reviews post. So let's check out the result. Yes. So we will expect to see response being sent from version 1, version 2, and version 3 of the reviews in a round robin or by rotation, in a round robin manner or by rotation. So it's 3, 2, 2, 1, 3, 1, 1, 2. So it's quite evenly distributed between the three versions of the reviews post. So now that we defined a specific virtual surface for reviews, and in this specific virtual surface, we will specify that 90% of the surface traffic will be sent to version 2 of the review post, and 10% of the service request will be sent to version 1. So it means that there will be no involvement from the version 3 of the reviews part. So first of all, let's create the waypoint. See. First, we check that this dual waypoint has been deployed as a gateway, and yes, we also see a waypoint proxy port has been deployed. One thing we can check is that you can see the waypoint proxy actually apply to the service account book info reviews. And this service account is the one that connect the waypoint proxy to the reviews port version 1, 2, and 3. We can check that in the settings, we can check from the settings of the reviewed ports that the service account is also set to book info to reviews. So we can describe deploy. And for version 1, you can see the deployed manifest has already configured the service account to be book info review for the reviewed ports. So the same findings also applied to version 2 and version 3 of the review ports. So you can see from the command here, the service account book info review is the one that connect the waypoint to the reviewed port. So after we create the waypoint proxy, we need to define a virtual service manifest and apply it. So here you can, we have to specify 10% of the request will go to version 1, and 90% of the service requests will go to version 2. There you go. By the virtual service. Yep, we have deployed the specific virtual service for review. That's and there you go for this one. So now we again we run the curl command loop check the access from the sleep pod to this review surface. So two things we would like to pay attention to is that we expect there will be no response from reviewed version 3 because in the virtual surface we don't mention we don't assign any request to the version 3 reviews pod. So that's one thing. Another thing is that we need to bear in mind that 10% of the requests will go to version 1 and 90% of the requests will go to version 2. So we will expect there will be many responses from version 2. And response from version 1 are only few and far between. Probably maybe one or two response from version 1 among many response from version 2. So let's start the loop. So for here's version 2. So you can see response keep coming from reviews version 2 pods. So far we only received response from version 2. Yep. So finally we see one response from version 1. In a sea of responses from version 2. Yeah. So we should be content that the result is in line with our expectation. And also we don't observe any response from version 3. Yeah. So that more or less come to the end of our trying and experimenting the ambient mesh with some with a limited amount of work. So finally, we just undo the Istio ambient mesh and the both info sample app. So first, we just remove the virtual surface from review. And then we remove the waypoint proxy. Followed by uninstalling the Istio ambient mesh. Sorry. If the last step is to enable the namespace, enable the namespace default regarding the ambient mode. So we are done with removal of the Istio control plane. Now we comes to cleaning up the book info app and the sleep point. Yep, so we have removed all the Istio, ambient mesh, and web load. Check port. Namespace, no. No, we removed the namespace of the Istio's Python system altogether. So there you go. We have complete a very brief and rudimentary session of getting started with Istio ambient mesh. I hope you find the demo or webinar useful, and also hope you are interested to explore the topics further. So till then, happy surface matching. Maybe catch up again. Bye bye.